Hey math kids, I wanted to show you this on Desmos, but before I did it I needed to start with some parameters. That's why I broke this into two videos. So we're given this piecewise function, and the first thing I want you to do is graph it on Desmos as one piecewise function. And so to do that, I'm going to have to teach you how. So I'm going to just move this right here. So hopefully we can still see it on the Desmos screen. Okay. So I already have it typed in here, but I want to take it like one step at a time. So I'm just going to say y equals, then we're going to do these curly brackets like this, and then we actually start with the domains. So the domain for the first piece is just x is less than 0. So x less than 0. If you want to, you can click the less than button down here. If this isn't showing, there's a little keyboard right here. And then you do a colon, and then you type the function. So the function is 2 to the x. So I'm going to do a space, but just go 2, and then shift 6, which is my caret, to the x. Once again, you could use this button to get that up there. Now if you see what it's drawn so far, it's just drawn this function, but it goes from negative infinity to 0 on the x-axis. This function without the constraints would look like that. And so see, when I turn this off, this only draws it for the domain that we've defined. Okay? Now if we want to do the next piece, we just say comma, and get that right there. And this one's just x, or sorry, we do the domain first. So we're going to say 0. We'll do a space to make it look a little bit better. So 0 less than or equal to x less than or equal to 5, colon, and then the function, or the piece of the function, we just do an x. So let me show you what that looks like. So that drew, so if we just do x right here, we get a line. But if we turn that off, we see that we only get that piece of the line that's defined from 0 to 5. So we're in between 0 and 5, and we draw that piece of the line. Okay, and the last thing that we're going to do on this part, comma, do the domain, so it's x is greater than 5, and we do a colon, and we say x squared. And if we just look at what x squared looks like, there we go. We see that x squared is not greater than 5, at least in the view that we can see. So we'd have to come all the way out here, turn this off, and see how we just have a little piece right here. So that's the first step. That's the first thing, just graphing the piecewise function. But something that I think is kind of fun, you may or may not think it is, but we're going to do it as a class. Whoops. Is I want you to modify this function, or this piecewise function, so that all the pieces touch. And so we're going to zoom in a little bit. Now we see the line segment and the place where this exponential function end. See how the line segment is down by 2? So if I go over here and I go to my x, maybe I'll show it on here first. If I just add 2 to that, or sorry, it's not 2, it's only 1. So if I just add 1 to that, see how those line up now? So on this piece, I'm going to change it to x plus 1. So now it goes exponential, and then it goes to a line. Okay, now the parabola, if we want to make that line up, we see it's pretty far, and we can make any piece line up. But what I'm going to do is I'm going to make the vertex line up, And so we see that this is up at 6. So if we want to jump this up to 6, what do we need to do? Well, we just add 6 on the outside, jumps up, and now we see that this could line up if we could just move it over 5. To move it over 5, change this to x minus 5. Now we see that it actually lines up right there. And so I just need to make those same modifications right here. And then they line up, turn off that one. And so we have some exponential growth, then linear growth, and then quadratic growth. And hopefully this is helping you with your translations. You understand how functions work, what you need to do to a function to move it. That's essentially it. So this is going to be a piece of your homework assignment, so just use this information. If you need additional help, come to Math Lab. Until then, calculator.